In this video, I'd like to talk a little bit about the nature of angles. And so basically, an angle is two rays that have the same endpoint. And that endpoint is called the vertex of the angle. So this represents an angle. We often talk about angles within a circle. So if you have a circle like this and you have an angle, this is what is called a central angle because the angle, vertex angle is at the center of the circle. And there's some connection, of course, to the central angle and what goes on in the circle. So first of all, we just want to get kind of make ourselves familiar with the size of angles, because we're going to talk a lot about the size of angles. And basically, we measure angles in degree, in how much it's been rotated. So most of you are pretty familiar with degrees. So like this one here is about 40 degrees. Here's an angle that's about 120 degrees. And so basically what we're talking about when we say 40 degrees, that means it's turned from the initial side of the angle to the terminal side of the angle, 40 tick marks of some measurement. So that's a degree is a really slight little measurement. So you're barely turning when you go 1 degree. So there's 40 degrees in here. So you can tell they're very small. Okay. But we also measure degrees in radians. And usually we think of a circle when you're talking about radians. So if you have a central angle, which means that, again, the vertex is located at the center of the circle, you can measure an angle in radians. This would be about this would be about pi over 4 radians. And a radian is another measurement of rotation, but it ties it into the arc length in a sense, because if we say that this is pi over 4 radians, that means that I have gone around the outside. So in other words, talking about the length of this arc. This arc is pi over 4 times the length of the radius long. So to make this maybe a little bit clearer is if I take a angle like this and I go, and let's say that that's 1 radian. That would mean that this arc here is the same length as the radius of the circle. If you've turned 1 radian, that means that the arc length on the outside of the circle is 1 radian, is the same length as the radius of the circle. Okay, so that's radians. But basically they're just 2 different units. If you have and the way they're connected is, if you go halfway around a circle, that's 180 degrees. And it's also pi radians. So that gives us a conversion ratio. So 180 degrees over pi radians is the same thing as 1. So if we wanted to convert back and forth between radians and degrees, say I have a 150 degree angle, and I want to know what that is in radians, I can multiply by the conversion ratio. And of course, because we want to get rid of the degrees and get radians, we put the pi radians on top and the 180 degrees on the bottom. That way the degrees cancel out. I'm left with radians. And we can simplify this, of course. The zeros cancel out. 15 and 18, 3 will go in there 5 times, 3 will go in there 6 times. So you end up with 5 pi over 6 radians. So 150 degrees is the same thing as 5 pi over 6 radians. So on the XYZ homework, they're going to ask you to draw some angles. So I'm going to hop there real quick and show you what that looks like. So here this is asking me to draw a 135 degree angle in standard position. Standard position means that the initial side of the angle is on the positive x-axis, and the terminal side would be 135 degrees turned around from there. So in the XYZ system, when you draw an angle, you don't have to draw both rays. We're assuming there's a ray right here on the XYZ, or sorry, on the x-axis. So you're only required to draw the ray on the terminal side. So 135 degrees, that would be over here on this side. That's 3 times 145, so it'd be exactly the middle here. So now the way you draw it is you click on the one side, and then you click on the other side to put it in the right angle. Notice once I've clicked it, I can move this around if I want to, wherever I want to, but I wanted it there where I had it. Make sure when you draw your angles, you go all the way out to the corner of the graph, or it won't recognize it as a correctly drawn angle. So the way I've done this, I think if I submit it now, it'll be happy with me. Yep, it's glad that I did it that way. So that's just a quick little lesson on drawing angles. So this is really just exercise. The first couple questions here are exercise in trying to figure out basically if you understand how big like how big a degree is, or what does 135 degrees look like, or 100 or 45 or 90 or whatever. Okay. So going back over here, and I think I'll stop the video for now, and we'll talk about the next topic in the next one.